All right, this video is about Venn diagrams, both about reading them, as we're going to do in example 1, and then creating them based on some given information, as we'll do in example 2. So let's get started here. We have a survey held at a winter resort where people were asked whether they like skiing or snowboarding, and were asked a series of questions. So the first thing you notice here, if you work from the outside to the inside of this Venn diagram here, you notice the big black rectangle. That signifies the entire sample that's being asked. Everybody who was asked this question is represented by this. And then you have a red circle and a blue circle. The red circle is also marked with S, and that's designated as people who said they like skiing. And the blue circle marked B stands for people who said they liked snowboarding. So, and then there's an overlap area, though that with the 9 in it, that signifies the people who said they liked both skiing and snowboarding. So both conditions are met. You see the 37, that stands for, that is part of the skiing circle, but not the snowboarding circle. So those 37 people represent the people who only liked skiing. And then similarly, the 15, which is part of the blue circle, but is not the red circle, that signifies people who said they like snowboarding, but did not say they like skiing. And then you see the 4 on the outside there, that's in neither circle. Those are the people who said they don't like either one. So you can see everybody here is represented. 37 plus 9 plus 15 plus 4, that gives us 65. So 65 people must have been asked the survey, and that's actually the first question. So I don't have a lot of room, so I'm going to do this with my answers. 65 people were in the survey because that's what all 4 of these numbers add up to. Secondly, the people who said they liked both activities, well, that's going to be the overlap, and that's right there, that 9. That 9 right there is going to be the people who like both activities right there. The people who like neither activity, well, these 4 out here are the people who they are not in the red circle or the blue circle. So they don't like either activity. So we're going to say that 4 people don't like either one. Not sure why they're at a winter resort, but that's okay. The people who like skiing. Now, this is going to, this kind of highlights something that we have to be careful of when working in Venn diagrams. So it would be easy to say, oh, the people who like skiing, there we go, that 37. Well, that's only part of the answer, because when we ask a question that only names one of the conditions, it doesn't say the people who only like skiing. It's the people who like skiing, whether or not they also like snowboarding. So we're not only using the 37, we're also throwing in the 9. And that's the entirety of the red circle, the red skiing circle. So to find that answer, we are actually going to do a little bit of computation here and add up both of those parts of the red circle, the 37 plus the 9, which of course gets us 46 people out of these 65 who like skiing. And then finally, who liked exactly one activity? So that tells us not both activities, so we're not going to count this one. And of course, we're not going to count the people who don't like any activities. We're only going to count the people who only like skiing or only like snowboarding. So again, doing a little math, 37 plus 15, 47, 52. So there are 52 people who like exactly one activity. So that's how we read a simple 2-condition Venn diagram. Now, we're also going to, in this next example, create our own. I've kind of put together a template here that we're going to fill in as we go. So in a group of 40 boys, in a group of 40 boys, that number is going to be important. There are 40 boys total. 23 have dark hair, 18 have brown eyes, and 26 have dark hair, brown eyes, or both. One of the boys is selected at random. Determine the probability that, and then we have a bunch of questions. So a few things to notice here. One is that we're being asked for probabilities, just not numbers, okay? The second thing here is, interestingly enough, the 23 and the 18 already add up to more than 40 boys. So that signifies that we have some overlap. We have some kids who we're going to who are going to fall into the both category, that overlap category. So we have to know exactly. We don't know exactly how many. So we're going to have to do a little investigative work to get there. So first, let's build our Venn diagram, and there is a strategy to this. So pay attention to the order in which we do things. First thing we're going to do is pretty simple. We're going to label our circles. So I'm going to make the red circle D for dark hair, and make the blue circle B for brown eyes. So the red circle stands for dark-haired kids, and the blue circle stands for the brown-eyed kids. So we're going to, a cardinal rule, I think, is in constructing Venn diagrams and putting information into, from a written problem into a Venn diagram so that it makes sense and is accurate and reflects all of the possibilities involved, is to work from the position of the neithers and the boths. We're gonna deal with those first, and then from those, we're gonna do a little math to get the ones who only meet one condition, if that makes any sense. So, what I see here in this problem, we have 23 have dark hair, 18 have brown eyes, so we already know, we're already over 40. We know that there's going to be some both. And then pay attention to this next part. 26 have dark hair, brown eyes, or both. So 26 out of the 40 kids land in here, or in here. That means the rest of them are going to be out here in the neither land. So let's see how many that is. We've got 40 total, and 26 land in the circles in some way, shape, or form. That means 14 of them are neithers. So I'm going to write my 14 out here, okay? So we've got that. Now, what that does is it leaves us, if we take our 40 minus those 14, well, we can see we're going to have 26 left. 26 left for the circles. Now, just how do we distribute those 26? Now, we're going to, again, work from the position of establishing the neithers and the boths first. We've already done the neithers. Let's find the boths. So we're going to find this overlap spot. So what we're going to do here is we are going to take our 23 plus our 18. 23 plus 18. So our 23 dark-haired kids and our 18 brown-haired kids, which is 41 total. But then we're going to subtract out, that 26, okay? The 26 kids that we have left over, okay? And that tells us, because what we're doing there is we're counting the kids who we're told to either have dark hair or brown eyes or both, the kids there, or the dark hairs plus the brown eyes, and we are subtracting out the kids that we know we have left. That's going to tell us how many fit both categories, because that way we're telling us how many kids effectively we are counting twice, and that's 15. So 15 goes there. Okay? So now we're going to establish our singles. Our ones who only have dark hair or only have brown eyes. Okay, so we know that 23 kids have dark hair, but 15 of those fall into both categories. That leaves us with 8 kids who only have dark hair. Similarly, we know that 18 students have brown eyes, but 15 of those fall into the both category. That leaves 3 for the only brown eyes category, and now we have a complete Venn diagram. Now, what we can do to check ourselves is to do a little addition and just make sure we have the right number of total folks. So we have 8 plus 15 is 23, plus 3 is 26, plus 14 gives us our total people of 40. So we have accounted for everyone. Now let's answer our questions here. If I can choose a different color. Here we go. Determine the probability that he has dark hair and brown eyes. Well, dark hair and brown eyes in our Venn diagram is the 15. So this is going to be, let me go down here where I have some space. It's our overlap area, so it's 15. Now remember, this is a probability, so it's going to be 15 out of 40. Now, your teacher may want you to simplify that fraction, or they may want you to leave it there to provide maximum context. So I'm just going to give you both answers. We can divide both of those by 5, and we can get 3 eighths, 3 out of 8. Question 2, he has neither dark hair nor brown eyes. Well, that's easy. We can just read that straight off of the diagram, and that is 14 out of all 40. We can divide both of those by 2 and get 7/20. Number 3, he has dark hair but not brown eyes. Okay, so that's only dark hair. Well, that's going to be the 8 because we are cutting out the middle part there, the both, according to that question. So that's going to be 8 out of 40, which of course simplifies to 1/5. Now 4 is interesting, and it brings up a point that you're going to see a lot. He has brown eyes given that he has dark hair. That given statement means we are reducing our pool. We are reducing the number of people that we are looking at. We are only looking at the dark-haired folks, which I am now circling many times in blue. So that means our denominator is only going to be the dark-haired folks, which is 23. Now, of those 23, how many of them also have brown eyes? Well, not these guys. It has to be the boths. So our probability there for number 4 is 15 out of 23 because we have reduced our denominator because we've limited our pool. So I hope that's helpful. Keep working hard. You're putting in the work. Proud of you. Keep going.